Very good afternoon. We have a session on meteorology, so let us proceed. You can confirm that share screen is possible.
नहीं सर, नहीं दिख रही.
अच्छा, 1 minute. Let me confirm. दिखनी चाहिए. I am already sharing it. किसी को भी नहीं दिख रही. Let me try again. हाँ जी. Should be possible. Is it possible to see the shared screen now?
Yes sir.
Okay, very good. It is titled Intertropical Convergence Zone, ITCZ. So if you can see the shared screen, that is good. Then we can have a small discussion on this. By definition, ITCZ is a belt of low pressure. Belt of low pressure which circles the Earth near the equator, and near the equator you also have the trade winds, and these trade winds blowing in northern and southern hemispheres come together in this zone, intertropical convergence zone. This is the reason it is called convergence zone, because this belt of low pressure circling near the equator, trade winds are converging. North and south hemisphere trade winds are coming together. There is a lot of activity over in this zone, and this brings in this region, ITCZ, you have perpetual thunderstorms over very large areas. That's just by introduction and definition. So characteristic of ITCZ: high cloudiness, frequent thunderstorms, heavy rainfall. The doldrums, we will have a look at that, are also located in this area, in this zone. But the thing to remember is that the ITCZ shifts north and south seasonally, and it can have some very large shifts, seasonal shifts of 40 to 45 degree latitude over the Indian Ocean. This is one diagram which is showing you the location of ITCZ. In the dotted line, what you have is the month of July, dotted line. As we said, there is a shift in the seasonal with season, so broad line or bold line is denoting the convergence zone in January. One is in July, Northern Hemisphere summertime, and one is in January. Now, the winds which normally prevail over this area, over the tropical ocean, are called trade winds. They blow from northeast towards the southeast in northern hemisphere and southeast towards northwest in the southern hemisphere. This one. Please remember trade winds, why they were called trade winds? Anybody with an idea why they were called trade winds? Of course, they're winds, yes, but why they were addressed as trade winds? Because these winds were used to trade sailing ships. They are used to propel. When sailing ships were the propulsion was by wind, these winds helped to propel the ships. Therefore, they came to be known as trade winds. And the name has been retained. They still called trade winds. But then they blow normally northeast towards southwest in northern hemisphere and southeast towards northwest in the southern hemisphere. Something you will have to commit to memory. They were used, the trade winds in olden times were used for advantage, for speed. But then while they are blowing, the trade winds drive north and south equatorial currents westwards. So when they're blowing north and south equatorial currents westwards, they are transporting warm ocean surface waters in that direction, which is westwards. Then there are counter currents. So counter currents means something is coming back in the opposite direction, counter current. This may be better. This is the circulation of the trade winds and equatorial currents. Some of the diagrams you will need to draw and commit to memory. Because nothing will change. This is how the circulation takes place and it will remain like this. So around the equator, about 5 degrees north and 5 degrees south, northeast trade winds and southeast trade winds converge in a low pressure zone. This is why it is called convergence zone, because northeast trade winds and southeast trade winds are converging. Therefore, it has been named as Intertropical Convergence Zone (ITCZ). So you can remember this one, and you can quote unquote, the trade winds of the two hemispheres converge in narrow east-west corridor or zone called the Intertropical Convergence Zone. Why thunder showers take place is because warm and humid air ascending, going up in the ITCZ, gives rise to thunderstorms. Very heavy rainfall locally is produced. But then we have said that they move with season. The limits of the ITCZ vary with season. So it brings us to a question: why do ITCZ not have a consistent location? Because the Earth moves with seasons, the area which receives highest amount of heat energy from the sun also varies. Because of the movement of Earth with the season, the area which is receiving solar radiation or heat energy from the sun is also varying because of the movement of Earth with the season. And this will vary the location also of ITCZ. So if we just imagine something called the thermal equator around which ITCZ moves, this will depend on seasons. In fact, some cases, this shift can result in complete reversal of the normal trade wind patterns, particularly in Indian Ocean. Because of the shift, a reversal of the normal trade wind pattern can also result. The ITCZ has a role in monsoon. As we have talked, ITCZ is a low pressure zone located at the equator where the trade winds converge, north and south hemispheres trade winds are converging. It is a zone where air will tend to ascend after converging. So in July, ITCZ is located around 20 degrees north latitude and called monsoon troughs. This will encourage the formation of thermal lows over north and northwest India, the formation of monsoons in India. Because of the shift of ITCZ with season, the trade winds in the southern hemisphere cross the equator somewhere around 40 degrees east and 60 degrees east and then start blowing southwest due to Coriolis force. Then it becomes southwest monsoon. And of course, in winter, this whole thing is shifting. ITCZ moves southwards, so the reversal of winds from northeast to south and then southwest makes this being called as northeast monsoon, which happens in the winter time. Somewhere around October, November, of plains of India, you have what is called the northeast monsoon. Can you recall the term doldrums? Doldrums. Because of the convergence, the northern and southern trade winds come together in the ITCZ. But because the Earth is rotating, rotation of the Earth, the winds cannot really cross the equator without losing energy. They can cross the equator, yes, but during the process of crossing the equator, the winds will lose some energy. So instead of continuing over Earth horizontally, because they lose energy, the winds move vertically upwards towards the upper atmosphere. Then this is assisted by the heating of the Earth's ocean current by the sun, making the warmer air rise. When you're aware when the air will rise, it will, you know, develop into clouds. Because there is a lack of horizontal wind movement in the region, it came to be known as doldrums, without any wind, doldrums. As you have heard the synonym, many times it is said the vessel has run into doldrums means in problem, because in doldrums no wind is there, trade winds are lacking, and therefore the ships, which were sailing ships, used to lose speed. So much so that they had to lighten. And those days, olden days, just as a sense of recap for humor also, the ballast was only available like horses. They used to carry horses as ballast. So they used to jettison horses to gain speed. And this was typical of doldrums. There were no trade winds, and the ships, depending on wind propulsion, used to lose speed. So to gain speed, they used to lighten by throwing horses overboard. Of course, this is only for you know history kind of thing, not for an answer. But if you are asked what is doldrums, then this is the answer. The lack of horizontal movement in this region ITCZ caused a nickname called doldrums. Very light variable winds in this area, sailing ships used to lose speed. ITCZ moves with the sun, shifting with seasons that we have just now gone through, but generally speaking, this is going to give rise to what is called spring and southward movement during the northern hemisphere. Autumn. This will be nearly stationary over north of the equator. One minute. Yeah. So ocean current circulation also affected by ITCZ and the prevailing winds. Obviously, driven by winds, the ocean currents are also affected. Nothing new in this because you are familiar with these currents. You have used these currents maybe while navigating also. Some of them are very known, familiar, and used also during the course of navigation for facilitating speed, even on mechanically propelled ships like today. Because I'm very sure you've heard of this and maybe used it. Florida current, this one, Gulf Stream, flowing like this, which is frequently used in passage from Florida towards Europe. Cross Atlantic, Florida current or Gulf Stream is used so that you gain speed. And speed variation could be nearly up to 4 to 5 knots more than normal speed. Of course, the ocean currents itself is a dedicated topic. We can cover it sometime. Yes, we will cover it. But this came up because of the flow of currents due to movement of ITCZ due to seasons. The islands of Indonesia. Indonesia is completely made up of islands. This marks the boundary. Of course, boundary is not drawn, but these islands mark the boundary between Indian and Pacific Ocean. They do not completely block the flow of seawater, but they do cause interference. Because there are many passages in the islands of Indonesia, so waters do flow through them. But then it also results in evaporation, you know, and this has to be replenished by large amounts of water from other part of the northern Indian Ocean. This also brings about what is called the monsoon. One minute. The Indonesian islands block the interocean flow, and that leads to accumulation of warm surface water, subsequently linked to what is called the El Nino. This, I think you must have heard, El Nino effect. It causes disturbance, El Nino, El Nino effect.
No, sir.
No, you have not heard of it? Okay, never mind. No problem. We are going to talk about it. El Nino. It is called the El Nino effect. The meeting of the air from northern and southern hemisphere and convergence gives rise to what is called the intertropical convergence zone, and this fluctuates seasonally. The range of movement depends. It could be in some areas small, in some areas very large. The belt of separation between them has its maximum width on the eastern side of the Atlantic, and the other side it is lesser. That is why the bandwidth of this zone is varying or is said to be varying. But just to recall and remember, this area is marked by intense thunderstorms, very heavy convectional rain and thunderstorms. And of course, you have an area recognized over there inside the ITCZ, which is called doldrums, because the trade winds in this part are negligible, very minuscule. They were called doldrums because they used to stop ships in their track, ships which were depending on wind for propulsion. Monsoons, not for now. We can come back to it. Monsoons. Narrow belt in low latitudes, separating two convergent air masses, which is converging, originating in different hemispheres. This is called the ITCZ. The zone is called the ITCZ. Must remember and write that the zone fluctuates seasonally with the movement of the sun. So its range of movement is small over the oceans and large over the continents. But the mean position lies north of the equator for most of the time. Horizontal convergence will vary from day to day because of the cloud cover, rain, and the receiving of the solar radiation. Okay. ITCZ has a implication for aircraft also, although not really connected with us. But just to get the meteorology part, hazards are associated with cumulonimbus clouds, which can result in icing, turbulence, lightning, and wind shear. So, trade winds do play a part even in airspace. Cumulonimbus, rain bearing, so it will have an impact. These clouds are present in the ITCZ and can result in icing, turbulence, lightning, and wind shear. Now, what are trade winds? Defined as steady and persistent winds which blow on the equatorial side of the subtropical high pressure system in both hemispheres. So, as this air moves, the Coriolis force deflects air to the right of air motion in northern and to the left of air motion in the southern hemisphere. Coriolis force. I'm sure you remember it, Coriolis force. When these trade winds from each hemisphere approach each other, then the rising air creates instability. The rising air, after the trade winds have approached each other from different hemispheres, they rise and creates what is called instability of the atmosphere and also a result of cumulonimbus clouds. So, as a generalized thing, in northern hemisphere the trade winds blow from northeast, while in southern hemisphere they blow from southeast. Generally speaking, generally speaking. So when you talk of weather associated with trade winds, normally okay for flying, for aircraft. But as they move, as they progress, they gather moisture. Clouds become more developed. So on the western side of the tropical oceans, it is more cloudy than the eastern side. And if the trade winds pass over land, for example Hawaiian Islands, then they result in showers because of the orographic lift. Do you remember what is orographic lift? Orographic lift. किसी को याद नहीं है ओरोग्राफिक लिफ्ट क्या है? ओरोग्राफिक सेकंड मिनट्स का सब्जेक्ट था ओरोग्राफिक लिफ्ट फॉर क्लाउड फॉर्मेशन. Give me a minute. If you're quiet means maybe you have forgotten. Let me see if I can locate some diagram for it. So orographic lift. I think we had covered the topic of clouds, if I'm not mistaken. Okay. Orographic clouds are basically formed when uh, air mass meets obstruction like a hill or land mass. This will make the air rise against the mountain itself. This will result in what is called a orographic lift, and then you will have a cloud formation at the upper part. So it is basically an uplift of warm moist air, and this can produce heavy rain because it is warm moist air which is rising, and when it is rising it is cooled adiabatically. When it is cooled adiabatically, it will give out latent heat, and that will produce condensation. Why did we reach here? Somewhere we stuck. Orographic. Yeah, over here. This is for orographic lift. This is the land barrier, the mountain over which the air is rising. Warm, moist air is rising, giving and getting cooled adiabatically. You remember what is adiabatic lapse rate?
Yes,
Where
sir.
without any exchange of heat from outside, the loss of heat can be done without any exchange from outside. Adiabatic, hidden. So this is what is showing you the build of orographic clouds. Clouds produced by the airflow over hills or mountains, and sometimes referred to as wave clouds. Clouds, like in this picture, resemble a pile of plates. Orographic cloud is continuously formed at the windward edge and evaporated downwind. So on the windward side, the cloud is forming, but on the leeward side, it is evaporating also. Because both things are true. When it is rising here, it is getting cooled adiabatically, it can bring rain, but when it is descending, it will also lose heat.
सर
हाँ जी प्लीज.
सर वो आपने नोट्स नहीं डाले सर, तो
यार,
प्लीज आप नोट्स डाल दीजिए सर, कार्गो वाले जो सुबह कर रहे थे सर हम.
हाँ यार, यू राइट. अच्छा, एक काम करते हैं, विल डू इट डेफिनेटली. इसी
हाँ
क्लास
जी,
में विल डू इट. Just let me just go through this topic
हाँ जी.
because it's not going to finish anyway, but we are going to do it. No worries, Chetan, no worries. I also have it in mind. Thanks for reminding, we will do it. So we were talking about this one, and trade winds play a part for the formation of what is called monsoons. But one thing I wanted to know, I'm sure you remember Coriolis force, because this is going to play a vital role in study of meteorology. Coriolis force always plays a part. Trade winds is definitely a marine term because this was used to trade. Sailing ships use these trade winds to go or propelled by wind. Therefore, it is a marine term, trade winds. Now, there was something about El Nino. Somebody said he has not heard it. So, this is defined as abnormally high sea temperature on the eastern Pacific Ocean, having a profound impact on global climate. El Nino. Abnormally high seawater temperature in the eastern Pacific Ocean. In fact, our next topic is going to be greenhouse effect, in which El Nino is going to play a part. So how is this happening? El Nino effect. Trade winds are pushing warm air and water towards the western side of the ocean. Trade winds, because they're blowing that way. And cold water takes up the place from the deep ocean on the eastern side of the Pacific. Let us say along the coast of Peru and Equator, eastern side. The weather in the western Pacific is therefore characterized by low pressure thunderstorms, which are normally referred to as typhoons. Water temperature in the east central and west eastern side of the Pacific becomes abnormally high, and waters in the western Pacific are cooler in comparison. This phenomena is called El Nino. And why? Again, just history, just for fun's sake. You know, this was called El Nino by the South American sailors who noticed that this normally occurs in Christmas time. So El Nino or boy child. But now it is known as El Nino, even in meteorology. This does cause concern. The El Nino effect does cause concern because tropical pneumonic storms, typhoons, etc., all thunderstorm activity is associated with it. Global warming is also, there is a part played by El Nino in global warming also. After an El Nino has passed, waters on the western Pacific become a lot warmer in comparison. The upwelling of cold water will take place because this warm water is going to be replaced by cold water along the west coast of South America. And then El Nino gains more importance. In fact, this is opposite of El Nino because following El Nino and upwelling of the cold water, you will have opposite of El Nino, which is called La Nina. The effect of El Nino, which is part of your syllabus also, you may have a look at this. El Nino effects. Warm and very wet weather in Peru and Ecuador. Severe flooding because of this. Warm and very wet weather means torrential rain. Normal than usual weather is wet in Brazil and Argentina also. In the southwestern USA, cool and wetter weather. There's one thing, of course, this causes a decrease in hurricane activity in the western Atlantic. So that is only the good point about the otherwise very gloomy picture. By definition, right? By a description of El Nino. You may note these points. These are the effects of El Nino. This one. you must memorize this one. Trade winds, the definition. Steady persistent winds which blow on the equatorial side of the subtropical high pressure system in both hemispheres. The definition of trade winds. So we will continue, no problem. We take a break, we come back, meet at 15:45 and we will continue. At that point of time, you can remind me also for, for something you want in the link. Okay. Right, we meet at 15:45, gentlemen. Candidates, 15:45.